Here's a little homework help on page 244, problem number 29. I want to just walk you through an example of these word problems because they all work pretty much the same way. I just want you to understand what is really happening when you find the two answers that are asked for in this particular word problem. Okay, so let's just read through it. We have this equation that represents the motion of a projectile. That's just an object that's being fired. Maybe it's a bullet or a rocket or whatever the case, but it's being fired straight up. And we have this initial velocity information, but here's the key. We're given this quadratic equation, and we're told that h represent how high the projectile goes over t, time in seconds. So we can know at any given, after it's fired, after so many seconds have passed, how high the projectile goes. And if we turn this around into more familiar terms, which you may want to do, we could write it like this, just putting the quadratic term first. This is a little bit more familiar to us. This would be more like the standard form that we've been working with. Okay, so you're not doing any harm. In fact, it might help you to right off the bat just turn this around so that the a term is in its familiar spot here in front of t squared. A is negative 16, and the b term, the b number, is the coefficient of our linear term, which in this case is 64. Okay, so this is just a parabola that obviously opens down. All right, this isn't really necessary, but maybe for this first example, if you could kind of get an understanding of what's happening here. Since we're doing height over time, then that means that as time passes, and this is in seconds, we can tell how high the projectile is. So, for example, after no time has passed, then it's still on the ground. But over time, it should reach a certain maximum point, and then because of gravity, it should come back down to Earth. Okay, so just rough sketch. We've got a motion in this way. It's being fired. It will reach a maximum point, and that's called the vertex. And then at that point, it will start to come down. Remember another word, the word vertex comes from the word turning point, or the word meaning turning point. So the projectile gets to a certain height, altitude, and then it turns. It obviously reaches the ground. So the reason why I'm going through this extra explanation is because really the whole goal of this problem is find the vertex. The vertex in this particular case is represented by the variable t. You know, normally it's x and y, but in this case, as time goes by, we're able to tell the height. So instead of x and y, we have t and h. Okay, well, remember that the AOS is a line that goes right through the vertex. And in this particular case, the AOS, we usually say x equals a certain number. Well, in this case, that's t equals a certain number. Okay, so the answer to the AOS, t equals some number, is going to tell us how much time it takes in seconds for this projectile to reach its maximum height. And just think back to when we did some graphs the other night. How did we find the AOS? Because that's really going to be the answer to our time question. How much time did it take to reach this highest point on the parabola? And we said there's a little formula that we follow. It's the opposite of b over 2a. Okay, well, again, I've already labeled a and b for you in this function. So we're going to do the opposite of b, which is 64, over 2 times a, which is negative 16. Okay, and this is, again, going to represent time in seconds. All right, so 64 divided by negative 32 is negative 2, but we're going to do the opposite of negative 2, which is positive 2. Okay, so what we've discovered is at 2 seconds, okay, remember seconds go along the x-axis. At 2 seconds, our projectile is going to be at its highest point. Okay, so the answer to find the time the projectile needs to reach its highest point, 2 seconds. Okay, so that takes care of this first question. And then how high will it go? Well, the answer to that is finding h for that t that we just found. So in other words, all you're really doing is finding the vertex. And the x-coordinate of the vertex will be the time necessary, and the y-coordinate of the vertex will be the height question, or the answer to the height question. So all I do is take my 2 and plug it in for t in this function. And simplify. So once again, you can use your calculator for this if you need it. Okay, so this is just negative 64 plus 128, and we simplify that and we get 64. Now putting it in the context, h represents height in feet, so the maximum height of this projectile will be 64 feet. So that's my answer to how high will it go. Okay, so we took care of t in seconds. T is 2 seconds. In 2 seconds, this projectile will reach its highest point of 64 feet. So if you'll follow that same line of reasoning as you're doing numbers 28 and 30, they're very much the same, different functions, but you go through the same type of process. You're basically finding the vertex. And hopefully working through this problem will help you with those. But if not, feel free to contact me if you have any questions.